So we are now at part 3 of how to solve financial maths question. And again, quickly just recap. We understand that in our exam question, we have either a situation of once-off payment, therefore compound interest formula, or we are converting the yearly to monthly rate or anything similar, or we are talking about many payments. And with many payments, this is where we understand the situation get more complex because we have a choice between the SN formula that actually works always, the sum, geometric sum formula, or amortization formula that work only at a very specific situation. And in part 1, we were in detail talking about how do we make choice about that formula. In part 2, we did some example. We applied that to specific example, and the same I'm going to do in this next video. Apply again that knowledge, because like I said, the biggest issue here is when it comes to SN formula is to identify what am I putting in place of A, in place of R, and in place of N in any given example. And like I explained in video 2, I came up with a way of dealing with that formula in a way that I'm hoping it's easy to remember. Okay, so let's have a look at examples today in this, part of the video. So here we were talking about Quiva in previous part. So she had a loan and she here been repaying that loan for 3 years. And at the end, she still have some part of that loan left. So she want to now repay it in just one go. And then the bank is telling her, okay, you know what, we can change that to just 1 year. And then 8,761.77, this is what is left after the 3 years of payment. We have the yearly interest rate given to us. So we understand that this is about not once-off payment, not in this part conversion, but this is about many payments, and she's still going from debt to zero debt, and it's at the end of the month that she is at the end of each month. So in the first part here, we actually have to find what monthly interest equivalent to a yearly, because we don't have for this particular one. So we know that that is our part of formula 1 plus I to the power of t, that is equal 1 plus I to the power of t, where we are saying 1 year is equal 12 months. So we just need to identify what we're going to put in place of I and t. So when it comes to 1 year, the one we have, so the interest rate is 0.0, too many zeros. Let's write it again, 0.553, and then time is 1. Here on the other side, the time will be 12, and I is the one I'm looking for. Now, we do need this value here because it's needed in our second part. So the interest rate we should be getting is 0.45%. That will be the equivalent. And then in part 2, we therefore have to find the money she repays each month. Okay, so again, let's identify those items that would go in SN formula or amortization formula. So the loan 8761, that's my sum. That's my sum of all those repayment. And in the amortization formula, that is the principal. That's my P. Now, again, the time and the N, that means all periods. So she is repaying here 1 year, isn't it? So 12 months, 12. The interest rate, like I've told you from that part, we found that will be 0.0045. Then value of R, like I said to you, always is the same. 1 divided by 1 plus the interest rate, so it will be 1.0045. And now here we are looking for value of A. That is the monthly repayment. And here we are going to be looking, that's the part, so we are looking for that F value. 1.0045 is divided by. That's what we are looking for. Now I just want to, this is simple, you saw it in, don't have to do anything here, but I just want to sub in those values in the formula to just show you how that is done. So I am looking for what? This value here, isn't it? So first I eliminate that by the denominator by multiplying both sides by it. So on one side of the equation I have my Sn multiplied by 1 minus r, and then I am left with a multiplied by 1 minus r to the power of n. And again, to eliminate that, I divide both sides by 1 minus r to the power of n. So then that's goes. So therefore, I am left with this. So let's just fill that in. So my Sn, that is 8,76176, multiply bracket 1 minus r, 1 over 1.0045, and everything divided by 1 minus, and again, r 1.0045, and that r is taken to the power of n, which is 12. Now what it equals is equal that. So that's my f I'm looking for, divided by 1.0045. So here we have to do one more thing. We have to multiply both sides by the denominator in order to get the value. But it will work the same. The value we're going to get in both cases, whether that a or that f here, will be the same.